Okay, so let's go ahead and get started. This month, we're covering practical BGP for enterprise engineers. Um, it's a big topic, you should be aware that you can't really cover all of BGP in an hour and a half. You can't even come close. I could do a week-long course on BGP and not cover everything. But we are going to focus on kind of practical BGP, best practices, troubleshooting, design, etc., specifically for connecting your network to a BGP network. And we'll go through a couple of use cases. We'll start out pretty easy with an introduction to what BGP is and why we even use it, and then some basics on things like terminology, path selection, right? And then we'll get into some of the more advanced things like configs, and we'll go from kind of basic to intermediate, routing policies and how to update those, which is in a lot of ways the heart of BGP. The flexibility with policies. And then we'll wrap up with filtering, validation, securing, and troubleshooting BGP. Okay. And as I mentioned, if you do have any questions, please just either raise your hand or just put them directly into chat and we'll get them taken care of. So hopefully by the end of this, you should have a pretty good grasp over both E and IBGP, and we'll talk about what those mean. How you're going to want to configure BGP in several different use cases, what those common use cases are, a number of best practices, and then kind of getting it operationalized for your company, right? What are the ways that you want to monitor, troubleshoot, design, deploy, etc., right? What you're not going to get by the end of this, you're not going to become a BGP expert, right? You're not going to be ISP ready. You're not going to go pass a cert just on what I can show you in an hour and a half, right? First of all, we're really focused more on enterprise BGP here and more on best practices than being worried about certs and so forth. That being said, everyone who RSVPs, whether they attend or not, will get a copy of the slides. I've got a number of links in here. If you are trying to work on getting certifications and so forth, you can go follow some of those links and read some of those papers and delve a lot deeper into BGP. BGP, I would say for most network engineers that focus on routing, BGP tends to be their favorite routing protocol. There's a lot to it. There is a lot to it. It is so flexible. It's so amazing. Just in my career, I started doing networking in 1995. Actually, one of my mentors, Ed Frankie, is on the call, kind of co-hosting with me today. And I think, we both learned things like OSPF and EIGRP and everything. And then when you got to BGP, your eyes really got open. If you were a routing geek, BGP appealed to you right away. So if you really enjoy routing, I think you're going to really like what we covered today. But, again, if you have questions or feedback, just let us know. So what is BGP even, right? Well, it's something called a path vector routing protocol. So it's neither distance vector nor link state. Rather, it's a path vector protocol. It was, and it's important to keep in mind BGP's original intent when it was architected as a protocol, because that gives you a lot of insight into its default behavior. Not that that can't be worked around, but it, by default, what it was built to do. So it was originally created just for ISPs, and it was for them to deal with the growth of the internet, meaning at that time, tens of thousands or hundreds of thousands of prefixes, and yet remain loop-free. And now we're at over 1 million prefixes, and we still want to remain loop-free, right? So it has a very, very different roots than something like OSPF or EIGRP, which were really built for enterprises. In many ways, BGP is a tale of two protocols, the internal BGP and the external BGP. We've got several slides that we're going to cover on that. And then why do a lot of routing people really enjoy BGP? A lot of it comes from it being policy rich. I have lots of different types of policies I can write. I can apply them directionally for both inbound and outbound updates. I can be very sophisticated in my pattern matching. Towards the end of today, we're going to talk about regular expressions and using those in more advanced BGP situations. And that policy richness really appeals to people. It's also quite possibly where BGP gets its reputation for being a complex protocol. I don't want to say that it is complex or anything, but it can be a little more complex in some ways than OSPF or EBGP. However, that complexity allows you that feature richness. And so to me, it seems worth it. To you, you can make up your own mind, right? And then why do we even care about deploying BGP in the enterprise? Well, it's often used when we have redistribution, like at our network edge. So think about SD-WAN, for example, right? I've got some overlay, and I'm probably going to have to redistribute between my internal networks and my WAN edge, my SD-WAN edge, right? BGP is a good way to do that because it's policy rich, right? Why else do we care? Well, it's very scalable and very well documented. It may be the best documented routing protocol out there. And unlike, say, EBGP or OSPF, which while both being open standards, I'd say BGP is a more adhered to standard. Absolutely, people add their own trinkets onto BGP. I'm not saying that they don't. However, that kind of minimum viable product concept is stronger in BGP than it is in something like OSPF. And then in the last, 15 plus years, there have been a lot of features that have been added to BGP to make it more enterprise friendly, right? And so it's become more and more pertinent to the enterprise. It really started with the advent and adoption of MPLS technology, which really required BGP in a lot of cases. And when that happened, they started to realize, wow, there's this gap. There's a gap in skills in that we've really only invested in ISP engineers to become BGP experts. And there's a gap in features because enterprises want to do things with their BGP that it wasn't really designed for. Let's talk about some terminology. And the first one is autonomous system, or AS. An autonomous system is just a group of routers under a single administrative domain. So one group of people, one company or something like that probably administers all the routers within a particular domain, right? In BGP, that's kind of what makes up an autonomous system. So a good natural explanation is if you're connecting your network via BGP to, I don't know, Verizon's network, right? Those are two different autonomous systems. You're administering your network and they're administering their network, right? Two autonomous systems there, right? We represent those autonomous systems with something called an autonomous system number, or ASN. A lot of people use AS and ASN kind of interchangeably, and I don't really have a problem with that. Just be aware they're actually not the same thing. An ASN effectively represents an AS, right? And if you have to go register your BGP or your AS and your ASN and so forth, you're going to dive deeper into the nuances between an autonomous system and an ASN. Most of what you're doing, though, is worrying about the ASN itself. And originally, this was a 16-bit number. It eventually was expanded up to a 32-bit number because we ran out of ASNs effectively. And I'm not going to go through all this in depth, but I just want you to be aware because you can see ASNs in different formats. The two most common formats are AS plain, which is just an integer, right? So 6328 or 123.897 or something like that, right? That's AS plain. The other one that you see most commonly would be AS dot. Before we get to AS dot, though, there was an interim called AS dot plus, which basically broke the ASN or the AS plain format into high and low order bits. The first 16 bits and the second 16 bits got separated with a dot, hence AS dot or AS dot plus. And we called those first 16 bits mappable space. We call it mappable space because it adheres to the original 16 bits that were launched when BGP was first created, right? And then the higher order bits, which come after the dot. I've got a link in here. You can go see the math on how to do this, right? I don't see a lot of people who use AS dot plus. I see a lot of people who use AS dot notation. AS dot notation basically just simplifies the AS dot plus to drop deleting 0 for the low order bits so that AS plain 7899 still just looks like 7899, but AS plain, this giant number that I have on the screen, ends up looking like this other giant number with a dot in between that I have looking on the screen, right? So again, if you're looking to do things like cert up and understand deeper, then you absolutely want to go to this link because you're going to be asked when you're studying for your CCNP core exams or when you're doing your CCIE lab exams and things like that. You're going to need to know how to go from AS plain to AS dot plus to AS dot, right? However, if you're just setting up BGP in a practical way for your enterprise, you probably need to know where to go look up that information, but you don't have to ingrain it into your your deep memory. Let's talk about some more terminology. I mentioned before, in a lot of ways, it's a tale of two protocols. Those two protocols are IBGP and EBGP. To be clear, there's just a single protocol, BGP, Border Gateway Protocol. However, there's two different formats in which it runs, internal and external. Internal BGP is the BGP rules for running within a single autonomous system. And the external BGP is the rules that govern running between two different autonomous systems, right? And we'll deep dive into this. AS path, this is a really important concept as we're going to see throughout. This is basically the path in ASNs or autonomous system numbers that a router takes to get to any particular prefix, right? So if I want to go from the edge of my network over to some other network, say some Google, network or something like that. The AS path is the autonomous systems represented as autonomous system numbers that I'm going to have to traverse to get from my source to their destination, right? Next hop is an important attribute. It's the next hop to reach a prefix. We'll dive a lot deeper into this when we get into IBGP. Local pref or local preference. This is an important attribute within an autonomous system. So it's an IBGP only thing, but within an autonomous system, it allows you to determine one path being preferred over another, right? In general, it's a number, and it is a number. And in general, the higher the number, the more desirable that path is, right? So you could raise or lower local pref in your autonomous system to prefer or de-prefer a particular path. AS path prepend is used to help influence path selection outside of your autonomous system. So it's more of an EBGP thing, right? And in general, the shorter AS path is more desirable than the higher path. And we'll go through examples of how to do AS path prepending towards the end of today's session. And then lastly, we have communities. If you're familiar, I'm not going to spend a lot of time on communities today, but if you're familiar with route tagging in, say, OSPF, communities are similar. I'm not going to say the same, but they're similar in BGP. They're similar. Part of the reason that they're similar is, while indeed it's identical to a route tag in terms of it's just a numerical value that we can tag into a route and then set a policy against that tag later on, or in this case, against that community later on. There are also 4 very special communities that only would apply to BGP, and that's the internet community, the no advertise community, the no export community, and the local AS community. Actually, the first person who ever helped introduce me to these special communities is my partner in crime today, Ed Frankie. And sure enough, it came up every time I took the CCIE lab. I did have to know those 4 special communities. I think it's probably still the case today. And then session states. When we build our neighbors in BGP, we're going to get a series of session states. I'm really going to cover 3. Just be aware there's more than 3. There's 6. But the 3 you're going to see the most common are idle, active, and established. And one thing to note right away about BGP that's different from all other routing protocols is that BGP is reliable. It runs over TCP 179. And so these session states are based on the capability to form a TCP 3-way handshake and then a BGP session to exchange routes. So we start in an idle state, which just means I have not even tried to make a 3-way handshake. You'll be idle, for example, if one end is configured, but the other end hasn't been configured yet, right? Active means I'm actively attempting to establish a TCP session with my peer router. And then established is indeed a situation in which I have established that TCP session, and I've also got BGP keep alive now going across that session, and I'm ready to exchange prefixes, right? So while you need to know all of these states, particularly if you're trying to do things like certifications, the 3 that are most helpful to you when you're just doing practical BGP in your enterprise would be idle, active, and established. So a lot of people think, oh, it's active, so that must mean it's good. I'm actively using my BGP. No, active means I'm attempting to establish a TCP session, but I have not yet successfully done so. Hopefully you'll go from active to open sent, open receive, and established. The reason I point out these 3 is when you do a command like show IP BGP summary, you're much more likely to see one of these 3 bold commands, or states, I should say, session states, rather than the others. You might catch the others, but they tend to be very quick. They go by real fast, whereas idle, active, and established sometimes take a little bit longer. So let's talk about that change between, or the similarities and differences between internal and external BGP, right? So as I mentioned before, internal BGP or IBGP, that's the BGP that's used within a single autonomous system. And external BGP is used between autonomous systems. Some things they share in common: they both support triggered updates, and those updates are batched. The batched updates might not be terribly important to you unless you're taking full internet routes. However, if you work at an ISP or you have a use case where you need to take full internet routes, batching the updates is really important so that we don't overwhelm a router, and also so that every update contains as many prefixes as it can. So I'm not also burning CPU cycles on processing hundreds of thousands of updates, right? So that's what it means by batching them. And they are triggered. By default, we have very long hello and dead intervals on BGP. These can be changed. When I say long, by the way, the hello interval by default is 60 seconds, and then the dead interval is 180 seconds. So, you know, that's ridiculously long when you think about it. 3 minutes to declare my neighbor is dead, right? So a lot of times these are moved off of defaults. I commonly see between an enterprise and an ISP to go down to 2060. I see pretty commonly within an enterprise to go to 10 and 30 or even 5 and 15, right? We're not going to get into it today. There are other protocols you could run like BFD or bi-forward detection, which would allow you to keep your default long hellos and deads, but speed up convergence when you lose a neighbor, right? We're not going to get into BFD today, but maybe in another session we could go through some advanced routing stuff that would kind of talk about that a little bit. Oops, sorry. The updates are reliable, as I mentioned. They're done through TCP. They both support policy-centric routing. They're both equally scalable. They can scale to millions of routes, right? Both of them explicitly configure their neighbors, right? So there is no neighbor discovery in BGP. We have to manually program all of our neighbors. And they do support equal cost multipath load sharing. However, it's not automatic. You would have to enable it. And this is a good example. The long hello and dead and the ECMP are examples of, remember, what was BGP originally created for? It's created for these ISPs to remain loop free and deal with high numbers of prefixes. And so things like fast convergence or ECMP, those were not really important at all to the BGP process when it was originally done. Some of those updates we talked about over the last 15 years, though, created capabilities to lower those hellos and deads and to add in ECMP support. Let's go down a little deeper into IBGP. And remember, it's a tale of two protocols. I'll just tell you right now, IBGP in general is considered more complex than EBGP. There's more governing IBGP than there is EBGP. EBGP tends to behave a little more like just a standard routing protocol. So what is IBGP all about, right? So first of all, when BGP was first written, IBGP was really meant to be fully meshed. Remember, it's written for those ISPs, right? So even if you were a small ISP and only had 20 IBGP speakers, that's 190 sessions per BGP router, per IBGP router, right? Just for IBGP, right? So for those who don't know, the formula for computing the number of links in a mesh network, it would be n times n minus 1 divided by 2. So if I take 20 and multiply it by 19 and divide that by 2, I get 190. That's where I'm coming up with that number. And large ISPs might have well over 100 IBGP speakers, right? So you can start to see like, wow, that's a lot of BGP sessions. So right away, we need to deal with one of the first oddities in IBGP, which is this full meshing is not based on physical connectivity. Normally, if two routers, if we say that they're neighbors, it means that there's a cable that connects them, that they have a network in common, right? Not so in IBGP. IBGP, what I really mean is that I can establish a TCP session, right? So that I have to have logical connectivity. I have to be able to reach all my IBGP neighbors. I have to have reachability in the IP routing table, right? So we'll see this in a lab in a minute, but it's already a little bit different just from that perspective, right? The other thing is it would obviously be ridiculous to have a large ISP with 100 or 200 routers and think that I could take the time to fully mesh all those, right? That would just be a ridiculous amount of work. We're not going to deep dive here, but again, if you are interested in going deeper, two things you would want to look at in IBGP for scalability would be route reflectors and confederations. Both of these technologies also play an important role if you do overlay networks, like software-defined networking, whether it's SD-WAN or whether it's SDN in a data center or some other type of overlay, you often see route reflectors and confederations. We also see route reflectors quite often in cloud networking, by the way. So they're worthwhile topics. I just don't have the time to go into them. Right. You might ask, why do I need IBGP to be fully meshed? That's a great question. We're going to go through an example later on where we realize in enterprises, that's a pretty loose requirement. A lot of times we don't need IBGP to be fully meshed, and we'll go through that in a few slides. But in an ISP, you do. And it's really because the whole purpose of IBGP is to transport all these external prefixes to other autonomous systems that might be across my internal network, right? And so IBGP was meant to run on the back of an IGP such as OSPF, right? This is why IBGP is often considered the more complex of the two sub-protocols, because it's really meant to run with an IGP hand in hand. And this is why we do things like I mentioned, things like you have to have reachability via a valid route, for example. And we'll take a look at that in a few slides. So let's talk about some IBGP configuration recommendations. In IBGP, I would strongly recommend all your neighbors form relationships via their loopback IPs. Do not use your interface IP addresses for IBGP. Use your loopbacks. This is just from a best practices perspective from a router ID and from um, an update source. And we can kind of take a look at that in a minute. We're going to go into a lab. This means that if I have like, 2 or 3 different paths and one of them goes down, I don't have to rebuild my BGP, my IBGP relationship. It falls back to that IP reachability in the IP routing table. So if I do it off of a loopback, which is a logical interface that virtually never goes down, and that's in my IGP, I can maintain that IBGP session state much more reliably. As mentioned before, an IBGP neighbor has the same ASN, so you're going to use the same remote AS value when you set up and declare your neighbor. For loop avoidance, IBGP actually uses split horizon, so something we're very familiar with from distance vector routing. We're going to talk about next hop behavior, but effectively in IBGP, it's important to realize that the AS path gets updated when there's 2 fields that kind of get updated when a prefix leaves one ASN and crosses into another ASN. And those 2 attributes that get updated are the next hop attribute and the AS path attribute. Those are both going to come up a little more later on, but that next hop attribute gets updated to the IP address of the exiting router that it is peering across from an EBGP perspective. And there's a requirement in IBGP that that next hop be reachable, right? And then the administrative distance of IBGP is 200. It's very high. Why is it so high? Because it's meant to run in conjunction with an IGP, right? Let me come over real quick and show you what I mean about this next hop. Let me just make sure all my routers stay active. So I've got a little simple network. R1 is running both EBGP and IBGP. It's EBGP to R3, IBGP to R2. We can kind of see that, show run. Okay. So you can see his autonomous system is 77. So here I've declared a neighbor at Autonomous System 77. So you know that's an IBGP neighbor, right? And you can see I've also declared a neighbor. Remember, our neighbors are explicit in BGP at 100.64.0.2, and the AS is 66. And so that's EBGP because it's a different autonomous system than me. And if we do a show IP BGP summary, you'll see both neighbors are up, and I'm learning a prefix from each. Oh, sorry, I think I've got a sharing problem. Let me reshare. I thought I shared my whole screen. I guess I did not. Oh, I see what happened. Can you see that now?
Yeah, we can see it.
Okay, perfect. I see what happened. Okay. Here's all I was doing was pointing out, here's how BGP is configured on R1. Here's how he's neighbors. If I come over to R2, of course, he's neighbored with R1, as I mentioned. You can see he's receiving two prefixes, one from R1 and one from R3. And he has a BGP table, show IP BGP. And here's his BGP table, right? And on his BGP table, you can see his next hop to get to R1's loopback is indeed R1's loopback, which is reachable in the IP routing table. If I do a show IP route 1.1.1, sure enough, it's right in there in the routing table, right? So there's two tables here, a BGP table and an IP routing table. And in IBGP, I need some synchronization, so to speak, between those two tables. He doesn't need a next hop for the 2.2.2 network because that's his loopback. The 3.3.3, which is the loopback on R3, well, his next hop is this. Show IP route 100.64.0.2. It's not in the table. So he's never going to have reachability to this network because this next hop attribute was updated when it exited ASN 66 and came into ASN 77, and it got updated to the exiting interface. If I come over here, show IP interface brief, it got updated to the exiting interface of the exiting router in the other ASN. I can update that over here, though. I can do this. I can come in and go into router BGP 77, and on my neighbor, I could say next hop self. Now, if I come in, if I do this, you're going to see it hasn't really updated. So remember what we talked about with BGP. It's a very slow protocol. In a lab, we're going to talk about clearing neighbors later. But spoiler alert, we'll talk about when to do and when not to do this command. But this basically hard resets all of my neighbors. I redo my TCP sessions, right? And so now if I take a look at my BGP table, you can see that 3.3.3, which used to say next hop was this IP address, has now changed to next hop of R1's loopback. Let me just go back and share the other screen. Okay. Let's talk about EBGP, right? EBGP tends to be a little bit easier because it behaves a little more like a normal routing protocol, whatever that means. It by default is meant to be directly connected, so I'm not relying on any kind of underpinning IGP, which makes sense. EBGP is running between two different autonomous systems, right? So it's meant to be directly connected. You could change this, but it's not common, and I wouldn't necessarily recommend you change it. We're going to get into securing EBGP towards the end of the presentation, and you can do it. It just complicates things and perhaps unnecessarily. Because it's directly connected, no IGP is required. EBGP has quite a low administrative distance, whereas in IBGP, we are meant to work with an IGP, and I don't want to take over from that IGP. Set my AD very. In EBGP, I set my AD to be very low because it, right? So just be aware of that. Its main loop avoidance is not split horizon, which wouldn't make a lot of sense here. Instead, its loop avoidance is something called an AS path check. So in EBGP, an AS path check basically says, when I receive a route, I will look at the AS path attribute. And if I see my own ASN in that attribute, I will deny the route, right? Because I know that I've originated it somewhere else on the network or on the internet. If it's getting fed back to me, I know that's a no-no, and I'm just going to drop that route. I will never install it, right? That's called the AS path check. Generally speaking, EBGP is more policy intense than IBGP. They actually support all the same policies. I mean, there might be specific things you would do that only make sense in an IBGP or EBGP setting. But we don't typically do lots of advanced filtering in IBGP. We do a lot of it in EBGP. That's because EBGP is typically running at the edge of our network where we enforce a lot more policy, things like redistribution, advertising's in and out, and how to deal with that and so forth. So while they support the same things, you tend to see more policy on EBGP neighbors than EBGP. Just a quick summary. I'm not going to really read through this, but you'll get it when you get the slides. These are all the different items. Oh, one thing I wanted to remind you of, if you're trying to influence path selection in IBGP, recall it's local pref, and in EBGP, recall that it's AS path, right? IBGP is not looking at AS path, and EBGP is not looking at local pref. So you need to remember whether I'm trying to influence something internal to my autonomous system or external to my autonomous system. And that's a good advice in general. Let's talk about path selection in general. We've kind of already covered a little bit about this with the next hop, right? If it's unreachable, then in IBGP, then it's not going to get installed. And then in EBGP, we look at the AS path attribute, right? And if I see my own ASN in the AS path, it's not going to get installed. So two types of loop avoidance there. Well, the AS path check is loop avoidance. The next hop is more of a reachability thing and something called synchronization with synchronization with the IGP. There's a number of ways to influence path selection. This is not exclusive. We're going to go through all the different ways you might influence path selection on the next slide. I'm not going to read through it, but I wanted to provide it. But some common ways. The first is weight. It's Cisco specific, although other vendors have the exact same concept. And it's okay for it to be Cisco proprietary because weight only runs on a local router. It is not a transferable metric. It only has meaning on the router that it happens to be on. No other router ever sees weight other than the router that you configure it on. The higher the weight, the more preference. So when would you use weight? You might use weight on a local router if it has more than one exit from it and you want to prefer one over the other. You could use weight and say, hey, this link has a weight of 65,000. This link has a weight of 31,000 or something, right? Local prep, we've kind of talked about. It's an IBGP attribute. And again, higher is more desirable. AS path is an external facing method, right? And in general, the shorter the AS path, the more preferable it is. So if I have two links and I want to influence my ISP to prefer link A over link B, I could AS prepend on link B and add my own autonomous system number more than once to the exiting prefixes. So if my ASN is 77, I could add in 77 two more. And you would always prefer link A because it's got fewer it's got a shorter AS path effectively. Towards the end, we're going to go through an actual example of AS path prepending because it's a really great way to influence path selection. And then lastly, on this particular shortened version is MED or multi-exit discriminator. This is definitely lower on the totem pole. I prefer AS path, but I want you to be aware of MED. It is vendor neutral. Everyone supports MED. But a lot of vendors don't really pay much attention to MED, and MED is kind of low in the path selection algorithm. Here's the full algorithm, and you can kind of see MEDs down in the bottom third down here. Those other things like weight, local preference, AS path tend to be a better way of influencing path selection. So now let's start taking a look at deploying BGP. And we've got several use cases we're going to look at. The first one is the most basic BGP you could ever set up, right? When you first start playing around with BGP in a lab, this is what it might look like, right? I have my router, my ASN, which is 88. I'm paired up with an ISP router. His ASN or their ASN is 66. And I just configure my neighbors, I put in my networks, and I'm done. Everything's done, right? Very simple and straightforward. It's EBGP only. There is no IBGP in this situation, right? Because there's two different ASNs, we know it's EBGP. When you add networks into BGP, we do it with the network and then the mask of whatever the interface would be. If you wanted to do summarization, you use a different command called aggregate-address. I don't cover aggregate address in this session, but it's very simple. It's one command. You could do something like, if I had a whole bunch of networks and I wanted to send them out as a single summarized network, I could do something like aggregate-address 10.2.0.0 mask 255.255.0.0 or something, and it would send it out as a /16. You have the ability to suppress the individual networks or not. So be aware that the default behavior in summarization or aggregate address in BGP is to add a summary route on top of all the specific routes. So you actually increase the size of your routing table. You want to suppress if you're going to try to just send a summary route. So what if we want to do something a little more advanced, right? So I've got a problem in this situation, which is if my router fails, I fail. If their router fails, I fail. If the link in between the two routers fails, we fail. Let's add a little redundancy. So we add a second router, but at the same ISP, right? So now if my router fails, I still fail, right? However, if my ISP's router A fails, I'm still up and working because their router B is still up. And if the link between my router and router A fails, I'm still good because I still have a path through router B, right? So this adds a little more redundancy. You can see it's all still pretty simple. By the way, I didn't do it here just for making it simple, but there'd also be an IBGP link between these two routers on the far right in ISP ASN 66, or at least there should be, right? It's an ISP network. I guess they can do whatever they want, but yeah, they would probably have an IBGP link there. However, if my router fails, I still fail. And if their ASN, if the ISP in general has an outage in their ASN for some reason, I fail, right? So let's add some more redundancy. Now I have my router, and I still have two links, but now they're going to different ISPs, right? So if my router fails, I still fail. However, if router A in ASN 66 fails, I'm still good because I still have a connection through ASN 77. If ISP with ASN 66 has a problem in their autonomous system itself, I'm good because I still have a link through ASN 77, and vice versa. If ASN 77 is having a problem, then I still have a valid path through 66. Now, in this particular situation, I still fail though if my single router fails, right? So let's deal with that. So I can add a second router, and now you can see I'm running IBGP down here, right? Um, so I have in router BGP 88. I have a neighbor with a remote AS of 88. That way you know it's IBGP. So now if one of my routers fails, I'm still good. If it comes back, I'm still good. If the other router fails, I'm still good. If it comes back, I'm still good. If either ISP fails for whatever reason, I'm still good. If either link fails, I'm still good, right? Now, let's talk about a big difference between ISPs and enterprises. Let's say you have this design in North America. Maybe I put it in Chicago or something like that. And it's serving internet for all of North America. And I do something similar to serve the networks I have in Europe. Maybe that goes in Germany, right? Like Central Europe. And maybe I have something similar in Asia. Maybe I put something in Singapore. I'm going to run IBGP at all three of those locations. IBGP is going to run in North America, in Chicago. It's going to run in Germany and Europe, and it's going to run in Singapore in Asia. However, I'm not going to most likely I am not going to bother full meshing my IBGP between those regions because really BGP is being utilized regionally only. There's no typically, again, you could come up with a scenario where this isn't true, but typically there would be no advantage to full meshing my IBGP between North America, Europe, and Asia in that particular case. It's a little bit different if you're an ISP. They're still going to full mesh globally, no matter where they're at. Um, However, as an enterprise, that's something that you can usually get away with, and you're going to be more concerned about it regionally. Again, are there exceptions? Absolutely. But those would be pretty out there scenarios typically. So one thing to be aware of is BGP is address family friendly. All the configs I've been doing have not dealt with address families, and most of the configs I'm doing are not. It's honestly just to simplify the space that I'm working within. The slides, as you can see, get a little bit crowded when I include address families. But address families were really designed around BGP because they really became popular in the MPLS days back in the early 2000s, right? And so it's no surprise that BGP has very robust address family support. You have two levels of configuration. You can have a global config. That's your general config, like your router ID, for example. And you could have your address family dependent configuration, like activating your neighbors, um, putting in your networks, etc. Those address families, it could be for two different routing processes like IPv4 and IPv6, right? It could also be for different VRFs, which is my more common use case, but that's because I do a lot of cloud networking. But you could also have an address family per VRF. And then you could set your policy if you need to redistribute between those VRFs in some way or something like that. let's go back to this scenario because you are susceptible to a real problem here, right? This was when we started to add two ISPs. So I want to point out something, right? So ISP 66 and ISP 77, what happens when they want to talk to one another? Well, uh, regardless of what happens, what you don't want to happen is you don't want them talking through your ASN, right? You do not want ISP 66 to think that they can reach ISP 77 through ASN 88, which is your ASN. This is called transit AS, right? And you do not want to be a transit AS. I've seen, honestly, more times than I can count, where someone has their internet edge continuously crashing because their two ISPs are trying to transit their, their little ISR 4400 or something like that, right? And so we can work around that. We work around that with something called a regular expression and an ASPath filter list. We're going to go into regular expressions and filter lists in a second. But I set this up. I say IP ASPath access list 1, and I'm only permitting this caret $sign. And what that really means is match on nothing. It's not that I'm permitting nothing. What I'm really saying is the ASPath attribute has to be empty. Okay? There can be nothing in the ASPath itself. And the only time that happens is in an IBGP situation, within my own ASN. Because remember, I mentioned that the ASPath attribute is updated upon exiting an autonomous system, right? So when an update leaves ASN 66 and heads to ASN 88, the ASPath attribute gets added onto it, right? And it's no longer empty. And since it's not empty, I don't allow it. And then in the configuration, you can see that this filter list is applied outbound. So what does that mean? It means I'm only going to allow prefixes that have no ASPath at all out to my two ISPs. So ISP at ASN 66 only receives ASN updates that have no ASPath, which means my internal updates. And same thing, ISP with ASN 77 only receives the null set of ASNs, which would only be mine. 66 does not propagate to 77, and 77 does not propagate to 66, or at least they do not propagate to one another through 88. This is pretty important. Let's talk about these regular expressions. I find some people love them. I fall in that camp. Some people hate them. Some of my coworkers fall in that camp. It's okay. You don't need to do regular expressions other than you absolutely need to know how to do non-transit AS configuration. But that's literally a single regular expression. That's it, right? So not too hard. I find regular expressions to be very helpful though. What are they? It's kind of a flexible way to do advanced pattern matching in BGP. You can do this for troubleshooting or setting policy via those ASPath filter lists or interrogating a BGP routing table, right? I have a link in here to a very comprehensive guide on how to write and all the flexibility you get with regular expressions. There's dozens of unique characters that can have different pattern matching capabilities. I'm not going to cover them all here. In fact, it looks like I'm just covering 5 of them here. 5 of the most common ones: a start of a string, an end of a string, a range of characters for a single space, and matching any single character, and then matching the space between ASNs and an ASPath list, right? These 5, you can start to see some power. We can now see what that caret $sign does. It matches a null or empty ASPath list. And again, the only null or empty AS path list is my internal AS path list because it's only, AS path is only updated. AS path is only updated on exiting an AS, right? Maybe I want to know all the prefixes that go through ASN 66. Maybe there's a problem. This does happen occasionally on the internet. I don't know if it's happened this year, but it happened last year and it caused a real problem on the internet where two ISPs had basically a war with one another. And I can't remember, I want to say it was Spectrum and someone else, but don't quote me on that. There's actually a great blog article writing up on it in Thousand Eyes, if you remember our Thousand Eyes session from last year. But basically, these two ASs were having a war with one another, and they were de-preferring one another's traffic while still keeping their connection to one another up. And so if one of those was AS66, I might say, let me find all the prefixes that go through AS66 because I might want to be aware that those may have slowdowns or interruptions because of AS66 is at war with some partners or something. So _66 underscore basically matches all the prefixes that pass through ASN 66. Likewise, sometimes you might say, what are all the prefixes that originate in an ASN? I'm working with some third-party business partner, and I say, hey, what are all the prefixes I might need to be aware of that you're originating? And maybe they don't have a network person that understands BGP, and they're like, I don't really know. I don't know. I just started 2 weeks ago, and the person who left didn't leave any documentation. Well, if you know what their ASN is, you could say, show me everything in _66$, and that means all the prefixes that originate in ASN 66. These are 3 really common use cases. But if you click on this link when I send out the slides, you can go see virtually an uncountable number of ways you could do pattern matching with regular expressions and see really cool capabilities. You could do things like, hey, send me full routes, but I don't really want full routes. I want everything in my attached ASN and one ASN out or something like that. You could do all sorts of different pattern matching. It's basically just a way to do pattern matching. And then you can build policies off of it with these ASPath filter lists that we looked at in the previous slide, right? I mentioned filtering and that filtering and route policy is very strong in BGP. It's why a lot of routing people really love BGP. It's why I love, well, one of the reasons why I love BGP. So on a per neighbor basis, I could filter routes based on route maps, distribution lists, or ASPath filters. I can influence path selection via things like weight, local pref, ASPath prepend, med. I didn't include med in here. These are not inclusive of everything. These are just common ones, right? And keep in mind, you can apply each of these per neighbor, per direction. I could have one route map that's influencing things outbound on neighbor A, another route map filtering things or influencing things outbound on neighbor B. Likewise, I could have a third route map influencing things on neighbor A inbound and neighbor B inbound. I could have a distribute list that's additive with my route map list, right? Same thing with the filter list. You can start to understand what I mean by it's a policy-centric approach to routing, right? Because I can apply all these per neighbor, per direction, right? So let's look at an example. Let's do ASPath prepending. I promised this earlier, and I think it's an important one to know how to do. In this case, I want to prepend across one neighbor to basically de-prefer that neighbor from reaching 10.17.5.0/24, right? So what I do is I set up a prefix list that says, hey, match on 10.17.50/24. Then I create a route map, right? and I match on that prefix list, and then I set my prepend. You can prepend as many times as you want. You're going to hit diminishing returns, right? 2 or 3 times is about as many as you want to do. Typically. I'm not saying always, but typically. And then it's important when you work with route maps, if you're not familiar with them, route maps are similar to access lists. There's an implicit deny all at the end of your route maps. So I don't want to just filter and drop all of my routes outbound. So I have an explicit permit at the end that doesn't match on anything. That means if you weren't matched in step 10 explicitly, you're matched explicitly in step 20, which just permits everything, right? So what does this do? Well, then I go into my BGP, and on my neighbor statement, I set a route map, and it calls the route map name, BGP-prepend, and I give it a direction, in this case, out. It only affects neighbor 172.16.0.2, but for that one neighbor, they're going to see the ASN 777 in there 2 additional times, right? So see it a total of 3 times. So my neighbor at 172.16.0.2 is not going to prefer that most likely, because let's assume there's also a neighbor at 172.16.0.6, for example, and it does not have that route map. It wouldn't see those extra autonomous systems. Now, this brings up an interesting point with AS paths. The only rule on AS paths is I cannot have my own ASN in the path. That's considered a loop on an EBGP, and I will drop it. Otherwise, it literally just takes the value, or the vector, if you will. Remember, it's a path vector protocol. It just takes the magnitude of the number of autonomous systems and counts them up. And it would say like, oh, I can do it by 3 ASNs here or 6 ASNs here. I will prefer this 3 ASNs. It doesn't pay attention to the fact that half of those ASNs are all the same, right? Which doesn't really make a lot of sense logistically. How would you pass through your own ASN multiple times? But again, it's not really paying attention. As long as it passes the AS path check, all it's then doing is adding up the total number of ASNs. Hopefully that makes sense. We're coming into the home stretch here. I mentioned early on that we were going to talk about session resets. This is another one where I've got a great link on here for the soft reset. So there's 2 ways to reset your sessions. Pardon me. So I mentioned BGP is very policy centric. I can set policies inbound, outbound on a per neighbor basis, and multiple policies per neighbor. And they're additive, typically. However, BGP does not dynamically update those policies. If you want these policies to take effect, there's exceptions to this, but if you want these policies to take effect, you have to clear the neighbor, right? And there's 2 ways to clear a neighbor. You can do a hard reset or a soft reset. The hard reset was what I did in my lab earlier, right? Clear IP BGP star, or clear IP BGP and put in a single neighbor IP address. However, this is disruptive. This is going to cause an outage. It might be a very brief outage, but it's going to cause an outage because it effectively tears down the TCP session state. So I have to reestablish TCP 3-way handshake. I have to go through all my session states. Remember, it goes from idle to active to established, right? And there's like Open Connect and some other ones in there as well. This one is the fastest in terms of you clear it and you just know it's going to work because I rebuild the entire neighbor relationship from the ground up, from TCP 3-way handshake up. So I know it's going to apply. Soft resets are not disruptive. And so they may be preferred because there won't be an outage. Unfortunately, with soft resets, they get a lot more complex. You may have to turn on some BGP features to enable them. your ISP or your peering router, if you control all the routers, it's not as bad. If you're working with an ISP, you need to verify that they're going to support soft resets, for example, so you can update some policies. But what it effectively does is it allows you to activate different attributes in the BGP routing table without tearing down the actual peering session. They have options for both in and outbound, right? And there's some pretty complex logic that backs up these soft resets, which is why I have a link in the slide deck, right? So my piece of advice is this. If you're doing something in a lab, just go ahead and clear your BGP neighbor. Do a hard reset. It's in a lab. It doesn't matter, right? If you're in a production network, try using soft resets. If they're not working or if your ISP doesn't support them, you're going to have to look at taking an outage and doing a hard reset. If you have to do the hard reset, there's a couple of things that can kind of help you out. If you have lowered your hello and dead intervals, that's good. You can enable some BGP features like dead peer detection type stuff, which will help out recovering quicker. You could run a protocol over the top like BFD, or easiest, just when you submit your change control, tell them there's expected to be about a 1 minute outage or something like that. It'll probably be less than a minute, but you go a little bit bigger. You say, oh yeah, when I apply this new policy for my ASPath prepend, or I'm applying this new policy for local preference or something like that, whatever policy you're applying, there's about a minute outage when I clear my IBGP, or I clear my IPBGP peers. Now, if you're taking full routes, that's what I just said, the minute outage, that's true if you're taking a small number of routes. If you got a one route like default, you've got a few thousand routes because you're paired up with someone and you've got something set where you're only taking a few thousand routes. It's going to be about a minute maybe at most, probably less. If you're taking full internet routes, then maybe tell them there could be a 15-minute outage. Full routes, because there's, I believe now over 1 million routes on the internet, you'll find it takes a lot longer because there's so many more route updates that have to propagate through. So just be aware of that. And again, use the link and that'll help you out. Let's talk about 2 different security mechanisms. The first one is super simple and straightforward, and that is just authenticating. I'm not usually a big fan of authenticating routing protocols. BGP is definitely an exception. I would always say you want to authenticate BGP. It is very easy, unlike doing it in other routing protocols where I have to set up my keychains and everything else. Not that it's impossible, it's just a little more complex. BGP is very simple. The other thing is your BGP as an enterprise, it might be different for an ISP, but as an enterprise, your BGP is usually a very small footprint. It's just a couple of routers, right? So operationally, it's much easier to maintain. If I have EIGRP running on 100 routers and I'm going to authenticate EIGRP, operationally, that's a lot more complex than 2 BGP routers, right? So in BGP, I would recommend you always authenticate. Now, keep in mind with EBGP, I have to coordinate that with the ISP that I'm working with, right? We have to agree on how we're going, what our string is. That's all. That's all it is. It's literally neighbor, password, string. It's that simple. No reason to not authenticate in BGP. The other one's a little more nuanced. It's called a TTL check. This applies to EBGP. And it helps protect you against certain DOS attacks, right? Basically, if they try to maybe overwhelm your router with some forged requests, EBGP, remember, is typically always directly connected, right? And so we know that the TTL should only decrement by 1. And so what I can do is I can kind of pre-process BGP updates. And if I see that the TTL is 254 or 255, that's fine. If I see it's 253 or 252 or something like that, I know to just drop it. Don't even process that packet. It's a forged packet, right? So if you did something funky, like you didn't want to peer off your directly connected link in EBGP, again, that doesn't really buy you anything in EBGP in most scenarios. Then you might have to change the TTL security, right? I find this is a good practice to follow, but a lot of people don't do it because it is a little confusing. And it's weird because I say, how many hops do I have? But the actual lookup is on what was the absolute TTL value, right? So if I say hops 1, it means the TTL has to be 254 or higher. And last slide, really, some troubleshooting and general commands. If you're bringing up IBGP and your neighbors will not come up, the first thing to check is IP table reachability for the update source. Usually in IBGP, I'm updating from the loopback. Is my loopback in OSPF or whatever protocol I'm using, right? The next one would be, is there anything that might be blocking TCP 179? Do I have an ACL or a firewall between these two IBGP speakers? If I have my neighbor relationship, but a route is not properly being installed, meaning I'm learning it in BGP, but it's not reachable, check that next hop attribute, right? Make sure that the next hop in the BGP table is reachable in the IP routing table. And if needed, utilize the next hop self configuration in IBGP like we did in the lab. For EBGP, if the neighbor's not coming up, you could check things like your authentication string, verify that they match, check your TTL if it's enabled, make sure that the ISP hasn't done something crazy like put in an extra hop. I don't know how that would even work, but just make sure they haven't done anything weird. And then some good general commands. One of the best commands, I used this earlier in the lab, show IP BGP summary. I love this command. This tells me so many things. It tells me what neighbor I need to switch over to my other screen. Okay. Here's show IP BGP summary. It shows me all of my neighbors I have configured. It shows me what their autonomous system is. Shows me what my autonomous system is. How many messages I've sent and received, how many tables I've updated, how long the adjacency's been up, how many prefixes I've received. It's just a great command. This will be more interesting on router 1, right? So I've got 2 neighbors, tells you who they are. It tells you what autonomous system they're in, how long they've been up, and how many prefixes I've received from each, right? So show IP BGP sum, it's a hugely useful command. I think I saw a question come in.
Wants to know if how are they going to get a copy of the webinar?
Oh, yeah. So I will send out slides probably tomorrow or Friday. By Friday, I'll send out the slides by Friday. And then next week, the link should be up on our YouTube channel. So we are recording everything and it will go up on our YouTube. I will send a second email when it goes up on the YouTube. So everything will be reachable and you can view it at any time. Another command, show IP BGP regex, that's for using regular expressions, and show IP BGP in general, which shows your IP BGP table. If I come back over here to say R2, and I do show IP BGP, this is the BGP routing table. Here's the whole routing table, show IP route. You'll see that that is a larger table. Here is just my BGP table. And notice the only route that has an AS path is my external route from router 3. Everything else is marked as I or internal, right? That's what I mean by that not becoming a transit AS or what we call the null AS, right? That's why that AS path filter works, right? And if I wanted to see show IP BGP regex, if I want to see all of the prefixes that are originated in ASN 66, I can further interrogate the routing table to just show me a subset of routes. This, if you're going to get into regular expressions, and again, everyone will get a copy of the deck, and if you like them, I love them, then just go Google for public route server and go telnet into one of the route servers. I usually use Hurricane Electric. You know what? We could just do this right now live. So this is an internet backbone router that I'm on right now, right? So I can do show IP BGP regex, and I don't really know any ASN, so I'll just pick one out. One of the ones we did earlier today in our example was 77. Let's see what is originated in ASN 77. Now, this is a big internet backbone router. I will just warn you, these commands on route servers like this, they take a long time to process, right? Here are all the networks. There's 4 networks coming from ASN 77. 128.244.0.0, 204.9.128.0, 204.9.129.0, 204.9.130.0, right? If I do show IP BGP sum, this is more like an ISP sort of thing, right? Here I can see all my neighbors, right? I can see all of their ASs. I can see their state. You can see some of them are in active state, which means, look, it's never been up, but it's actively trying to establish TCP. Here it's in a connect state, but it's never been up, right? And when you're troubleshooting, a lot of times you're just up arrowing on this BGP summary to see when does it transition. But look at this. Here I've got established states, and now I've transitioned into how many prefixes. He's learned 957,233 routes from this particular neighbor. So, total number of routes. Can you do, I don't know, can you do like human readable? No. It'd be nice if you could do a
You've
human
got
readable.
another question here, Jay, if you're
Yeah,
looking for.
yeah, go ahead. I'm sorry,
Uh,
I didn't see it pop up.
yeah, no worries. I know Dennis just had a follow-up question. Do you have a channel platform where you can explore pursuit of some government opportunities, example, Tulare, ScanSource, Sandler Partners, etc.? You're gonna read that in the chat.
Okay. I would say, well, it's a good question. It's one I don't have a simple answer to. It depends on the particular government entities. We work a lot with some people like Los Angeles County, for example. We work with a couple of federal defense contractors, for example. It depends a little bit on the regulations of the particular government entity. So what I'll do is at the end of this, I'll put my personal email into chat. And if you send me your request, I'll forward it on to the team in our company that deals with government entities. That's definitely not my not my specialty. I'm much more of an enterprise network engineer, so I'm dealing 99.9% of the customers I support are enterprises, from as small as maybe 500 employees to as large as maybe 80,000 employees, something like that. Oh, yeah. Okay. You remember me exactly. Yeah. So I still work with them, believe it or not. So yeah. Thank you, Dennis. That's all I have today. I'm going to go ahead and turn off.
Need help? Call our cybersecurity team and book a consultation with us today.